All right, so we're going to be talking about the graphs of secant and cosecant in this video here. So here's kind of a quick peek at what they look like. Kind of funky looking graphs. Honestly, they're a little more confusing looking, I think, with all the asymptotes and things that are going on here and how they're kind of disconnected than what they really are. Honestly, if we can graph sine and cosine, we're definitely going to be able to graph these. In fact, I'll kind of show you how graphing these are almost exactly the same process. We just need to change them around a little bit. Remember the reciprocal identities. So we have these are two of our reciprocal identities. And the reason we're kind of illustrating these is because we can represent cosecant as 1 over sine, and we can represent secant as 1 over cosine. This has a lot of implications for the graphs of these things. And so one of them is that there are going to be some values where cosecant and secant are undefined. And we learned a lot last semester about what sort of types of discontinuities that we can have when a function is undefined. And some of those are holes or asymptotes or some sort of jump or something like that. In this case, we have asymptotes. We actually saw them on the previous screen, right? We're actually going to have some asymptotes. And asymptotes happen as your input variable approaches a certain number. The output either grows or decreases without bound. So the output either goes to infinity or negative infinity. And that's what's happening here with these functions. As we approach, let's just examine this one for secant, as we approach an angle or an input here that causes cosine to go to 0. So for instance, like pi over 2. At pi over 2, we have an xy coordinate of 0, 1. So the cosine value is approaching 0. So as we go to pi over 2, what's happening is this number is getting closer, and the output of this function is getting closer and closer to 0. It's getting smaller and smaller and smaller from the positive side, because it starts at 1 and it's coming from the positive side. So what we're doing here is we're doing 1 divided by a very, very small number, which grows without bound. That grows up to infinity, right? Whatever number we wanted as an output, we could get it if we just get closer and closer to 0 here. Same thing is going on with cosecant and sine here. So any input value that approaches 0 for sine. So let's just think about it in terms of pi. So pi would cause sine to be 0 because the coordinates there are -1, 0, right? The sine value is 0 at the angle of pi on our unit circle. As we get closer and closer and closer to that, we're getting closer to 0. Our sine value here is getting closer to 0, which again causes us 1 divided by something that's very, very small. We're growing without bound again. So any of these values that make that happen will cause us to have an asymptote, because as we're approaching that constant, we're growing or decreasing without bound. We get that asymptote behavior. Yeah, so this can happen not just at these values at pi over 2 and pi for this one. They can happen at sort of any value depending on what other sort of transformations are being applied to our given function, right? If we do something that changes the period or phase shifts it or something like that, the location of our asymptotes will be changed as well. So again, let's just kind of go back to that screen of the graph. So hopefully you can see here, we talked about how there were asymptotes at certain values. So for cosecant, which is the reciprocal of sine, we have asymptotes at 0, we have an asymptote at pi, we have an asymptote at 2 pi. You can see the kind of the pattern here, right? And then if we go backwards, it's at -pi and -2 pi. And then here for the secant graph, we have asymptotes here at pi over 2 and -pi over 2 and -3/2 pi and 3/2 pi, right? So you can see those asymptotes at these sort of regular intervals. Notice here that these asymptotes are exactly pi units apart each time in the case of these really basic graphs and basic equations. That is, related to our period, kind of half of our period there, to have these asymptotes appear. Let's go ahead and keep moving forward. So here's the process we're going to follow for graphing cosecant and secant. And I'll kind of illustrate this by looking at the graphs on Desmos here in a moment. But here are the 3 steps we're going to follow. And this one is very packed. This step is actually real complicated because essentially we're just going to graph sine or cosine. That's basically what's happening. Now we're not going to draw in the curve, but we are going to plot all of the 5 friend points that we use to make these graphs. So if we are trying to use trying to graph cosecant, we're going to graph sine because those are reciprocals of one another. And if we are trying to graph secant, we are going to try to graph the cosine curve. Again, just the points. The points will help us graph. And then we do these 2 new things. So anywhere that there are midline points, maybe they're x-intercepts, maybe they're on the x-axis, but wherever the midline is, if it's shifted up or down, we're going to have vertical asymptotes because those are the values where sine or cosine is equal to 0, and that causes that vertical asymptote behavior that we just talked about on the last slide. And then after that, we're simply going to draw these sort of U-shaped parts that we've seen on there. So let me just kind of sketch this out real quick. So it's either going to be a U that's facing upward or a U that's kind of pointing downward, and we're going to make sure we're approaching the asymptotes cleanly as well. So let's say we're trying to graph a cosecant graph. Well, we're going to make all of our plotted points for a sine curve. So here's our 5 friend points, kind of the basic shape of that. This is our midline right in here, midline. So everywhere that we have a midline point, we're going to draw those vertical asymptotes. So I'll go ahead and sketch those in. So we'll have a vertical asymptote here, a vertical asymptote here, and a vertical asymptote here. So this is just going to be one cycle of cosecant, just like we always graph one cycle of sine or one cycle of cosine. We're going to keep that pattern going, and we're just going to be graphing one cycle of cosecant and one cycle of secant as well. So then we draw these U-shaped curves. So at the peak of the sine curve, we draw this U shape here. And that's one part of our cosecant graph. Make sure we're approaching the asymptotes and curving nice and smoothly. And this is a point that's on our cosecant graph. And then we'll do the same thing down here at this minimum. Make sure we, again, approach the asymptotes. And that's it. We graphed sine, which is somewhat of a complicated process, right? That involves setting the period, scaling, and all that. That first step is pretty loaded. I mean, that's like what we've been doing for the last few weeks here. So making sure we can do that part based on all the different transformations and things. But these 2 new steps are pretty easy. Draw in some asymptotes, draw some U's, and we're done. So this is what one cycle of cosecant looks like. Cosecant. Let's go ahead and sketch out one cycle of secant as well. So for secant, we would plot our 5 points for cosine. So let's just say we have a cosine equation here, and we get our 5 friend points. And we're not going to draw in the cosine curve, but we have our midline points, right? Midline is right here. We want to put those asymptotes there. So it's a little different than the other one. We have an asymptote here, and we have an asymptote here. Seems good. Looks a little different. Cosecant had 3 asymptotes because we had 3 midline points, whereas this one has only 2. And we're going to be able to draw a couple U shapes on the top and only one on the bottom in this case. But we don't draw the full U shape up here. We just kind of draw like this, right? We only draw sort of half of it. I mean, technically this part over here does exist, but it's not part of our one cycle. It's kind of part of another cycle that's kind of butting up against us. And the same thing that's happening on this side, right? We draw it like this because this is the start of our cycle right here, and this is the end of our cycle. And everything that's happening outside of it is part of a different cycle. It's technically part of the graph. It's just not part of the cycle that we are plotting. So I'll graph them dotted there, but they aren't part of our cycle. And then down here we have our bottom half, our bottom U shape. Man, I drew that pretty poorly, but we'll just have to use our imagination that was pretty good. So this is our one cycle of secant. So this is secant. And again, let me just kind of put a box around this just so we're clear about where the cycle is. So our cycle is right here. We're just looking at this section here. These little dotted lines are kind of what the graph would look like if we plot everything, but they're not part of the cycle. And you could imagine if we take another copy of this and set it right next to it, we take this little curve here and we match it up over there, it would complete that graph. So secant looks a little funkier than cosecant, but it's still just sort of based on the cosine graph, and we just make sure we draw all these things. Anyway, let's go ahead at this point and kind of take a look at the Desmos graph. Let's see some more cycles of it, just kind of examine what's going on there. So let me open these up. So here is cosecant. I went ahead and graphed these ahead of time just to make sure it's there. So you can see how, cycles keep repeating, right? There's more cycles. It keeps going on forever, just like the sine curve that we're examining. So we have both cosecant in red and sine in blue. And you can see the connection here, right? As we look at these, we have our points that would be our maximums and minimums of the sine curve. And we see how those are kind of like either the maximum of that U shape for the cosine or the cosecant, or the minimum of this U shape, and see how they're connected. You can also see that at these midline values, at every single midline value, you can see that's where a vertical asymptote is happening. You can watch as the cosecant graph is approaching that asymptote. And let's just quickly examine just a couple things here. Let's just say we want to change the amplitude, right? So we have an A value here. So I'm just going to put an A value in. I'm just going to make a slider for it, and I'll put it in both places. So right now our A value is 1. So our amplitude is 1, and we recognize that, I think, from the sine graph. But let's just say we want to make that amplitude go up. Let's make it go up to 2. Well, obviously we know how that affects the sine graph, right? It stretches it up, does the same thing. It just kind of shifts our cosine graph upward a little bit. Kind of cool. Just still stays connected there. No matter what we do with this amplitude, right? If we make it a big positive number, that just means our sine graph's gonna be a little bigger. It's just gonna kind of shift everything upward for us. Let's go back. Let's actually make it a negative. Right? What happens if we do it as a negative? Oh, well, that just means it's reflected, right? If that A value is negative, that just means we're reflecting it. So if we have a -2, same thing's going on. We just have a reflected sine curve, so our cosecant curve is also reflected. Kind of cool to see those connections. And we can do the same thing with the period. If we adjust the period and we put a 2 in there, all it's doing is scrunching in our sine curve, scrunching in our cosecant curve. They move together. No matter what changes I make to them, as long as they're both the same, they'll line up perfectly. So we can just always use this sine graph that corresponds with the cosecant graph to make it. And I'll just quickly show the secant and cosine relationship as well. Well, let's just add something to the end of it. Let's just add or subtract. Let's subtract 4 and just shift it down 4. Same thing's happening, right? If I shift it down, everything just shifts down together. I shifted down the sine graph, the cosecant graph shifts down accordingly. Nothing different is going on here. So, pretty cool. We just use the sine graph to graph the cosecant graph. Trying to get to that next tab, but the Zoom menu keeps popping up on me. There we go. So same thing is going on with cosine and secant. No matter what transformations we make to the secant graph, as long as we make the same transformations to the cosine graph, they'll just line up perfectly, always, right? If we want to, let's just say we want to shift it to the right pi/4, right? Let's just make that happen. Let me just copy this and just throw it up here. If I shift them both the same, they line up perfectly. It doesn't really matter what transformations we apply to it. They're going to match up perfectly as long as we have the same transformations. So when we're graphing these things, when we're graphing secant or we're graphing cosecant, we're just going to kind of pretend that they're sine or pretend that they're cosine, graph that mostly, don't draw in the curve, but graph it mostly, and then we do the 2 things that we need to do to make it secant or make it cosecant. All right, let's go ahead and go back to the notes here. So at this point, I'm gonna go ahead and stop this first part. In the next part, I'm just gonna run through a bunch of examples of doing this. I think about 4 of them, and I'll see you guys then.